Hello, everyone. Today we're going to cover Chapter 4, Forecasting, Part A. Before we get started, let's think about why we need to forecast future demand. Let's take an example. Let's say you're running a Japanese restaurant and you're using lots of raw fish every day. How long can you keep raw fish in the freezer? A couple of days. So let's say you're using raw fish for one day only. Every morning, you go to a fisher's market, you buy raw fish, and you use it during the day. And at the end of the day, if there is any leftover, you're going to throw it out. And you repeat this every day. What happens if you buy too much raw fish? You'll have leftover and you'll throw it out. You are wasting money. What happens if you buy too little raw fish? You will run out of raw fish and you lose sales. So it's very important for you to know exactly how many pounds of raw fish you need every day. So in other words, you need to forecast the daily demand of raw fish. So that's why we need to forecast future demand. In this chapter, we're going to talk about demand patterns, forecasting methods, and how to measure forecasting errors. So when we want to make a forecast, we need to follow some steps. First, we need to collect data on sales. For example, on March 10th, you use 3 pounds of raw fish, and the next day you use 4 pounds of raw fish, so etc. And like this, you need to collect your data points. Once you have your data points, the next step is identify the pattern of your data set. Is your data set horizontal or stationary? Or is there any definite trend? Or is it seasonal? Once you identify the pattern, you're going to use the pattern to find the appropriate forecasting method. And you're going to apply it to your data set, and you're going to make forecasts. And when time passes, you'll be able to evaluate how accurate your forecasts were. So let's talk about the details. Identifying demand patterns. If you have a data set like this, how can you identify its pattern? You can plot the data set on the XY plane. On the x-axis, you can put the date, March 10th, March 11th, etc. And on the y-axis, you can put the sales. So how many pounds of raw fish did you use every day? On March 10th, you used 3 pounds of raw fish. On March 11th, you used 4 pounds of raw fish, etc. So once you have this data graph, you see the pattern. Do you see some horizontal pattern with some daily fluctuations? If that's the case, your data set is horizontal. Sometimes it's called stationary. Now, this kind of data set is called time series because you are collecting data points over time. The next possible pattern is a pattern with a definite trend. Your graph can show an increasing trend like this or a decreasing trend like this. Now, the next possible pattern is a pattern with a seasonal trend. What do we mean by a seasonal trend? Something is repeated over and over every year. So this is what happened in the first year, and in the next year, you'll see something similar. If that's the case, your data set is seasonal. So what types of products do you think will show seasonal pattern? Almost all types of products are seasonal. For example, Christmas trees are seasonal, and Valentine's Day cards are seasonal. So let's look at some real data set and see if we can identify the pattern of each data set. We're going to look at 3 examples. Now, in this data set, we have the total building and construction activity in Australia from September 1973 to March 1995. So how can we identify the pattern? Let's plot this data set on the XY plane. So select the data set, go to Insert, Recommended Charts. Okay, so on the x-axis, you have the time. On the y-axis, you have the sales. So what type of pattern do you think this one has? Do you think this one is increasing over time? Yes. Now let's look at the next example. Now in this data set, we have the monthly Australian beer production from January 1991 to August 1995. So let's plot this on the XY plane. So on the x-axis, you have the time, the y-axis is the sales. What kind of pattern do you think this one has? It looks like it's horizontal. How about seasonal? Is it seasonal? To see if it's seasonal or not, let's plot the last 24 data points on the XY plane. So I'm going to select the last 24 data points, click Insert, and click Recommended Charts. So this is the first first year, and this is the second year. Do you think a certain pattern is repeating over and over again? Yeah, because you see the peak in the same month every year. Now let's go to the third example. In this example, we have the Australia monthly production of cars and station wagons from July 1961 to August 1995. So let's plot this data set. Insert charts. So you can see that the trend is increasing, and then it's it levels off. Do you think this is seasonal? To answer this, let's plot the last 24 data points. Let's plot data points. Now this is the first year and this is the second year. Do you think this is seasonal? Yeah, I think this pattern is repeating every year. So this is seasonal. Okay, so let's go back to the slides. So once you identify the pattern of your data set, the next thing you need to do is choose the correct forecasting method for your pattern. For example, if your data set is stationary or horizontal, you can use either the moving average method or the exponential smoothing method. If your data set shows a trend, you can use the linear regression method. If your data set is seasonal, you can use a combination of linear regression and seasonal factors. So let's start with the horizontal data set. The first method you can use is the moving average method. So let's say that you plot the data set on the XY plane, and this is the current time period. And we want to make a forecast for the next time period. So what's our best guess for the next time period? We know that the data set is horizontal, so the sales are staying at this level with some daily fluctuations. So the best guess for the next time period is probably this constant level. So how can you find this constant level? Remember, our data set has some daily fluctuations. So then how about averaging some of the data points? So how many data points should you average? The number of data points we're going to average is called the order of the moving average method, and it's denoted by n. So if the order, if you're using the moving average of order 3, that means we're going to collect 3 most recent data points and then average them. And that's going to be our forecast for the next time period. So for example, you can collect the observation from today and the observation from yesterday and the observation from the day before, and then average these 3 numbers. Then the average of these 3 numbers will be our forecast for tomorrow. Now, what happens if n equals 5? We're going to repeat the same thing. We're going to start from the current time period and go back in time until we collect 5 data points. And then we're going to average these 5 data points. And that's going to be our forecast for the next time period. So you can see that the forecast for the next time period is the average of n most recent observations. Now you can ask the following question. The forecast for tomorrow was the average of the n most recent observations. Then what's our forecast for the day after tomorrow? What's the forecast for 2 periods ahead of time? Since we know that this data set is stationary, the forecast for any future time period will be this constant level. In other words, the forecast for the day after tomorrow will be the same as the forecast for tomorrow. In fact, the forecast for any future time period is the same as the forecast for tomorrow. Let's take an example. Compute a 3-week moving average forecast for the arrival of medical clinic patients in week 4. The number of arrivals for the past 3 weeks were as follows. In the first week, we received 400 patients. In the second week, 380 patients. Third week, 411 patients. Currently, we are at the end of week 3, and we want to make a forecast for week 4. And we want to use a 3-week moving average forecast. So that means we want to average 3 most recent observations. So what's the most recent observation? 411. And the next one, 380. The next one, 400. And add them up, divided by 3. Then you get 397. Now that's our forecast for week 4. Now let's say that time passed and the actual number of patients arrived in week 4 is 415. Now we are at the end of week 4. What's our forecast for week 5? Again, we're going to use a 3-week moving average. That means we need to collect 3 most recent observations and then average them. So what's the most recent observation? Since we are at the end of week 4, the most recent observation is 415, and then go back in time and collect 3 observations and average them. The answer is 402. Okay, so that's our forecast for week 5, 402. Now, the next method we can use for the horizontal data set is the exponential smoothing method. The exponential smoothing method requires only 3 items of data. The last year period's forecast for this period, and the demand for this period, and smoothing parameter alpha, and this is a number, this is a given parameter that's between 0 and 1. And you can use the following equation to compute the forecast. The forecast for the next time period is demand in this time period times alpha plus the forecast for the current time period times 1 minus alpha. Okay, so this is another way of making a forecast. So let's yeah. So let's take an example. Consider the patient arrival data given in the table below. It's now the end of week 3, so the actual number of arrivals is shown to be 411. Using alpha equal to 0.1, calculate the exponential smoothing forecast for week 4. Assume that the forecast for week 3 made at the end of week 2 was 309. So right now we are at the end of week 3, and in week 3, we received 411 patients, and this was the forecast for week 3, and this was made in the previous time period. So under this setting, what's our forecast for week 4? According to the formula right here, the forecast for the next time period is demand in this time period times alpha plus forecast for this time period plus times 1 minus alpha. So take the demand for this time period times alpha, which is 0.1, plus the forecast for this time period times 1 minus alpha, and then add them up. And that's going to be our forecast, 392.1. So that's our forecast for week 4. And let's go to the next part. If the actual demand for week 4 turned out to be 415, what's the forecast for week 5? So that means time has passed. We are at the end of week 4, and during week 4, we received 415 patients. Then what's our forecast for week 5? Again, we're going to use the formula. The forecast for the next time period is the actual demand in this time period, 415 times alpha, plus the forecast for this time period, 392.1 times 1 minus alpha, and that's 394.4. So this is everything for this part, and I'll see you next time.